to put one under each one instead of trying to balance them both on one?
We have plenty, but
Okay.
isn't necessarily a desired way to go about the business of loading kilns. Others would disagree.
I guess I overdo it with the posts when I put my
Well, it depends if you're trying to get more
Did you see that?
stuff in or just
I
different
guess,
colors, you
I
know,
guess.
but Things
Well,
like
the
that
way-
are far and few between, though, you know,
Yeah,
usually here.
that doesn't happen all
I
that
mean,
often.
This is the first time I've ever,
4 kiln set accidents in my 27 years.
Oh,
not
see,
bad.
that's not
That's
too
not
bad at
bad.
all.
Figuring that we're
That's not
firing
bad.
the high fire kilns
At least once a
probably
week.
30 times a year, maybe more.
nicely put stuff
Still makes me
happens.
nervous.
Well,
My-
yeah,
my
stuff does
stuff.
happen, so.
Yeah. But it's never gratifying to have it happen.
No.
No, you have a lot of work and time invested.
Any other thoughts come to mind, even for the two of you who weren't here for the lecture? I'm not going to give the lecture again, but
Yeah, but for the only thing is like with her, the updraft and the downdraft, is there your opinion on what's better?
I have always preferred downdraft kilns because I get more sense of control over creating the
But these
uniform.
are updraft kilns that we
We have
have, right?
one of each.
I'm gonna have to really study and look at those things to see the difference.
Okay, could you go over that again then? I don't remember which is which. I guess I could look in
The one next
The
to
one
the
with the
door
hole-
is the
downdraft.
downdraft, and the one in the,
Facing us
sort of
is
the
the up-
middle.
The
yeah,
one in the,
Because of fire
the
that goes up.
inside one had a hole in the top of it.
That's the updraft one.
That's the updraft one? Oh, that adds the thing that slides
Because it makes
over.
things suck upward.
Yeah,
Okay.
yeah.
So, burners at the bottom, gases, combustion take place, exit out the top of the kiln.
This one right here. This is
In this particular version of a downdraft kiln, the burners are once again at the bottom of the kiln. Gases circulate up and then are drawn downward to exit through an opening at the floor in the back of the kiln, which requires, so if we look at the kiln sideways,
excellent plumbing.
there's a chimney, so the door's out here. You've got the work in here. Gas burners here and here. Gases go up and they eventually exit this way. And then there's a damper that controls the flue, so the gases come out here and then this damper pulls in and out. But it's the upward motion of the hot air in the chimney which creates enough draft to pull the gases back down to exit out the bottom.
That's what my kiln has, it has a back, chimney in the back. I'm gonna have to find out what I got.
And it seems, I mean, both of these create convective plumes, but the updraft one is gonna create
Yeah,
primarily simply upward convective plumes, whereas this one is gonna create almost a spiral.
Right.
Well, it's more circulate, it circulates
circulate.
better.
Okay, so the
So-
one with the hole in the, well, okay.
Those of you who are paying attention to the plans for firing out in the yard with the new soda kiln that we're building,
the downdraft soda kiln?
well, all the fires coming in from 3 burner ports on the side of the kiln and it comes in, strikes a wall of bricks called a bag wall, and most of the flame is deflected upward. Some of it, though, we leave openings in the bag wall so it doesn't create a big cold area right here. And eventually everything goes out through and then up the chimney. And this is referred to as a cross draft kiln. You might consider it a modified downdraft, but we're taking advantage of the directional movement of the flames and the gases to affect the surface of the ware during the firing.
Okay. So of the downdraft and the
Updraft and downdraft.
updraft and downdraft, which is preferable?
I prefer the downdraft.
Because
I
the
feel-
warm air is circulating through it more as opposed to pulling cold air up. Okay,
That's my take on
yeah.
it. So I
And we
built,
mostly use the downdraft one. Do
no, we
ever-
mostly use the updraft because it's larger.
Oh, okay, okay.
I have had 3 kilns in my career, each a downdraft. The first one, and you mentioned this, so I'll call it to your attention. There is one type of structure, generally with that kind of shape, that is a self-supporting masonry structure. It's called a catenary arch. The benefit of a catenary arch is you don't have to have a whole bunch of steel to keep things together. In a catenary arch, this curve is elegant to create by taking a horizontal straight line and 2 nails. You hang a chain and let it drape down with a background of plywood, and that's the arch. And the simplest thing to do then is you got a sheet of plywood behind here, take a can of spray paint, and it leaves a shadow of that curve. And then you build a device which is 2 plywood sheets like this and nail on boards between them, and that creates a structure for the curve. And you put that down where you're going to build your kiln. You got all those boards to support it. You put 2 wedges, these are really important, wedges underneath that edge. You stack the bricks on that frame, you pull out the wedges, you pull out the frame, and there's the arch of your kiln. Then you have to put a wall in the front and the back. So in most cases, when I built these, I had burner ports here, and on this side too, and the bag wall in here, and then the ware was stacked up inside that space. The flame strikes the bag wall. The bag wall's got penetrations in it, so some of the flame goes through, some of it's deflected out, and then in the back is this opening, so you have a chimney out here in the back, and all that chimney helps support the wall of bricks that you build up on one end, and on this end you just hand stack bricks for each fire.
Except mine happens to be a molded iron frame. It has an iron frame and with metal
wheels.
sides. It's not on wheels, I got it on a pallet.
Oh.
Interesting, thank you.
And there are many, many other variations. Hi, Brian. Hi there. Why don't you grab a stool and set up down here on the end? Brian, we're just about finished talking about what issues or subjects might still be on your mind after last week's presentation.
Your notes are a pleasure to read. I can read you writing very well.
Yeah,
Thank you.
type the rest of them for right here. So. I type all my notes, I just need it. So there's no,
Decipher my notes.
It's kind of connected, but maybe after trying to figure out what happened to my pots that fell down inside. Like, did it warp because it got too hot?
I see. Well, yeah, you're waving and I can see nobody else knows what you're talking about. So
Okay.
let's bring your pieces over.
I mean, that was definitely something I wanted to bring in and show you. I know I need a hydrometer. This one had way too much glaze.
Oh
you can
my.
you can see it dripped underneath here. It's even there's got
Down
a
a
big
little bit, huh?
there's a drip right here, a big
Oh, yeah.
knobby. And then so the idea was that these would be chip and dips up
Yeah,
like that.
a nice
and now all
thought.
you could use it for is like thick guacamole or something, you know.
I don't know, but they're rather interesting.
And it's a pain.
But when it gets warm,
You can
doesn't
make
it get hot
fountains
enough in
out
the
of
white
them.
when things cook
Oh,
and go
yeah.
up and when you go
Yeah.
down,
So
if there's
to
no
drill 'em.
support, it'll
Yeah.
Well, we don't
bend you
know.
on
I mean,
down.
I've had some that
What
come
were
out
they like
successfully.
when you put them in the kiln for the glaze fire?
Pretty straight, maybe a slight tilt. Like this one, it's scored and slipped, you know, real tightly. This one looks like it might have broken loose or something. I think this one just had. Look at all that extra glaze there. It's terrible.
That's because it bent.
It's
Puddled.
flat. See how it goes
Oh, it
flat?
puddled. Oh, that's why it dripped too.
See, it couldn't handle that weight of the glaze
Yeah,
itself. But this
yeah.
this one's kind of has me baffled.
Were the sides straight with the bowls? You could use. Were the sides supposed to be straight when you put the bowls on?
No, I bend them purposely. That's what I said. Target practice. That's exactly what I
No,
said.
they're perfect to make little fountains.
Actually, I
Oh, that's a
I really
great
like
idea.
this one.
Yeah,
I do. I
Yes.
think that's really,
I
But
think
what
they're
could it be
neat.
used for?
Water
Water
fountain.
Sold.
Fountains.
it's old.
Can't be sold.
So you put water down here in the bottom and you put birdseed up here,
Oh, that's
Yeah,
a
that would
great
work
idea.
too.
put it outside the window and,
It's a bird feeder.
A bird bath.
Yeah,
And
bird
feeder.
bath
Too
and feeder.
deep though, then they'll.
well, don't
they won't
put
get in
don't
it.
put too much water in there.
The glaze is lovely too, what you did on here too.
Okay, so Brian, you've made these before? At this scale?
High fire?
That's the biggest, one of the bigger ones.
And you've been able to fire them successfully?
Yeah, there might be a little tilt, and I don't mind a small tilt, but when it's getting like that, you can't. It's not even functional anymore,
So
except for shooting with the.
So what these demonstrate beautifully well is that this clay body during the firing goes through two major changes. One of them is vitrification, and during that period of time, the clay is shrinking. It's no longer clay, it's ceramic body, but in the kiln. The second thing that's happening is when it's shrinking, the clay is also soft. And so, to me, these look like the very logical extension of a firing in which during vitrification, the clay softens, gravity does what gravity does and pulled downward. And so, it just bent over during the firing.
Trying to come up with a way, like some form of brace on there.
Well, there's a couple things you can think about. One is you could significantly increase the thickness of the rim at the top, not the whole piece.
Right.
Create a stronger structural ring up here that would resist that bending as opposed to this fairly thin edge on both of these pieces. That might be one solution. Another is fire at a lower temperature. But then you need a different glaze arrangement.
Didn't you say you bent this rim over a little bit
Yeah, I
to
bent
put
it
that
over
on?
a bit.
It was folded over.
And that gives you, it starts it as opposed to.
If the bowls were lighter, possibly,
Sure.
and the rims were thicker, that's what you're
Okay.
saying. And maybe if I added a coil.
Now, here's another
Where
thought.
it's
You
connected? No,
you
that
set
one-
those
heavier.
essentially on the rim.
Yeah, I kind of like I use my metal rib and I flatten it. I flatten it, and then I set it up on there, and I balance it before I slip it.
Find a comfortable
So I find
spot.
the middle zone.
Okay.
And then I score it, slip it, and I put it on there.
So what if you folded this edge over as you've done, but now your bowl has contact both on the edge and on the, this is flatter
And on
here,
the side.
so that it's not sitting so much on the edge, it's sitting more on this, so this gets
that.
bent
Oh,
over
yeah,
further.
yeah. I see what you're saying.
Ooh, yeah.
And the bowl
it has
sits-
that flat part right
Yeah,
there. You're
yes,
talking.
yes.
So
Yeah.
bend it a little more, and then and make that the little.
Yeah.
A ledge.
That's the whole.
It's worth
Yeah,
a try, but I
that
tell
part.
you, it was painful. I lost over about half of my stuff.
You know what? I'd make them
water fountains.
Yeah,
That,
water
yeah.
fountains and bird feeders, yeah.
Thank you.
You're welcome.
You know anybody that could drill holes into it for a fountain?
Well, I should Just need the right drill bit.
It's fine.
Yeah,
Thank you.
Thank you. That's a very
Very
interesting
interesting.
opportunity to solve a problem and see the
Well,
results.
thank you for not seeing it as off topic. I was thinking,
Oh, no.
I come in here and right away I want you to look at my stuff. And figure it out.
Don't we all, huh?
Okay, today, the primary topic is to deal with glazed materials. Now, as a sense of context for this discussion, all glazes share some common denominators. You start with something that makes glass. And those pure materials melt at very, very high temperatures. And in order to assist with the glass forming or the glaze forming, we need to add material that promotes melting. Fluxes are materials which will lower the melting point when added to another material. We need to assist in the physical aspects of applying glaze to provide a material which serves temporarily as a glue, holding the mixture of ground up rocks to the surface of the bisqueware. And in almost all cases, that glue is the clay component of the glaze recipe. Finally, there are a variety of materials that can be used to modify the glaze, and they include things which affect color, opacity, and potentially the texture of the surface of the fired glaze. So our discussion of these 4 pages of materials that you were given at the start of the semester to research the nature of how these are used in glazes is to talk about each of these categories. Is that, it's this very simple explanation of how glazes are formed. And then there's a wide array of materials used depending on the temperature range at which we plan to fire. When we choose a clay body, we choose it for 2 reasons. The first is the ability to form the clay body. Form it into what? Form it into a teacup, a chip and dip combination assembly, a brick, a tile for kitchens. Why needs the volume to come down?
yeah, it's getting loud again.
Yes, that's perfectly acceptable. Let them
Didn't do any
know.
good.
You need a horn, foghorn, or an air horn, or whatever they call them.
Me.
So it's coming down.
We forget when
Okay.
we not
So form the clay body and then.
So we choose a clay body based on how we're going to form it
Okay.
and what we want it to look like after it's fired. So we're making building bricks, we'll choose a different clay body than if we're making teacups. For Brian, one of the alternatives that I suggested for him is he could fire these assembled pieces at a lower temperature where the ceramic body doesn't distort so much because it doesn't become so soft. But there's something to be said for high fire materials and glazes that sometimes has us begging results that aren't necessarily easily accomplished.
But isn't the clay different too? So it gets
a clay body, there are hundreds of thousands of variations of clay bodies. You chose B mix.
Different melting points?
Absolutely. A local
the
clay from San Luis Obispo. Most of the clay at the close of the brickyard was when they were excavating for foundations, and they would haul it in because they'd used all the brick clay available. When we did the foundation for our house, we had a soil test. We found out the wet to dry expansion contraction was 19%.
Oh.
That's 1 foot in 5. It's huge stress on foundations.
Yeah.
But that clay body makes really nice bricks when you add other coarse material to it. Until you get it too hot. And this one was in the firebox. The hot gases from the combustion caused that to first vitrify and then begin to melt and sag and distort. So any of our clay bodies, if we got them hot enough, are going to turn to glaze. Our low fire white clay body, when we put it in a cone 10 kiln, melts to form a glaze, and it flows on the shelf, and it messes up a lot of other people's work.
Yeah,
Yeah.
had that happen.
So, we're not talking about just cone 10. This is true of all ceramics, wide range of temperatures and circumstances. The first page of that 4-page sheet is labeled primary glass forming ingredients. And of those, the first on that list are 2 forms of feldspar. So Vi, since I'm really curious about the thoroughness of your research and what you've come up with,
Quite a bit.
I don't doubt. So will you start with a discussion of potash feldspar?
Potash. The presence of potash feldspar in a glaze or clay body has a more refractory effect on the ceramic surface compared to equivalent amounts of soda feldspar. The potash feldspar actually begins its melt at a lower temperature than soda. Once the melt begins, the formation of lucite crystals causes a slower and more
Viscous.
viscous, thank you, flow. Anyway, it's said to dissolve silica more effectively than soda. The high expansion and contraction rate of a potassium melter in potash feldspar causes the glaze surface to craze, and different potash feldspars have correspondingly different craze crackle patterns.
Okay, so you expanded the issues of discussion in part into clay body, but not inappropriately. If you will look at the recipe under its natural state for potash feldspar,
Yeah.
K, that's the periodic table symbol for potassium and oxygen. So potassium oxide is one ingredient in potash feldspar. Alumina, Al2O3, and silica, SiO2. Those materials are blended together in a melt, and in very rare situations, that material can come up from the mantle of the earth in circumstances that generate a dike or a seam in a crack and fill that in and then cool slowly. And this is pure potassium feldspar, gathered by 2 travelers who went to Custer, South Dakota last week and stole this sample off a mountain of...
Lifted it, not stole.
We sat on it first.
Lifted it, yeah, we did.
They ripped it off. They ripped it off in the name of art to come back for us to look at, because there are many forms of feldspar and many concentrations. So in this chunk of granite, all of that pinkish crystal that you see dispersed throughout the rock is the same. It's feldspar. But it would not be economically viable to try and extract it from the other minerals in the granite. And on a visit, the same, one of the two travelers came back with this chunk of potash feldspar.
That's gorgeous.
And at the processing factory in Custer, folks take that material and pulverize it and grind it up into a powder, which is awfully hard to distinguish from many of the other powders that we have in the back. But this is what we use in our studio when we think of Custer feldspar or potassium feldspar as we use it in the glaze. It would be very difficult to get this to hang on the side of your pot. But somebody's been kind
Is this
enough.
a combination of crystal and feldspar?
I think it's primarily feldspar, but it may have some quartz in there too. So that's what we're talking about when we refer to potash feldspar as an ingredient in glazes. The primary provider in North America for potash feldspar is Custer in the Black Hills of South Dakota. And they are so determined to give us a high quality product that they can blend as many as 700 different ore samples to give us a feldspar with a predictable and consistent chemical foundation.
Wow.
What else do they use feldspar in besides what we use or here? I guess there's some kind of commercial use
Well,
for it to make it.
Keep in mind that as ceramics artists, practitioners, we are at the very tip of the tail of a big ceramic dog. Pittsburgh Plate Glass manufactures glass windows and windshields and a whole variety of materials and projects. We could, if I forget the name of the company that actually produces the feldspar for us in Custer.
Oh, yeah.
Industrial Minerals Corporation or something.
Pacer.
Pacer. So it's only because of the rest of the industrial use of feldspar that we have it available to us.
Yeah, because it just didn't seem viable for them to be producing.
Honey, our
No,
toilets,
not for ceramics.
you name it, toilets, our,
Well, yeah,
our
they're made out
insulators,
of
our
slip,
washing,
yeah.
everything is,
Yeah.
of course.
So it's all part of the the industrial ceramics complex that we are just at the tip of that tail and grateful for it. Now, who's got some? Yes, Brian.
I just think it's neat that you bring us a piece of that because, like you said, you'd never, when you see it in powder form, you'd never think that that's
Not the same.
yeah, you'd never think that that's what it looks like.
Thank you,
I'm
Kathy.
all nervous. You
Yeah,
gotta
because you're
open
showing
that.
us pieces that are
The
pink.
box.
Oh, I've already looked at it.
Oh,
He's already
good.
looked at it.
Oh, good, okay.
And when it's ground up like that, we're back to a white substance. So
Yes, because the
it's so-
particle size is so small,
It loses
the
its
color
color.
is only apparent in its crystalline state.
Yeah.
You grind it up into a powder, the surface area goes up dramatically, and
Yeah.
the color is very diffuse.
But if we looked at the powder first, we wouldn't envision.
No. I would not
colored
get from
rock.
there to here.
Yeah.
And I probably wouldn't get from there to here if I hadn't stood in Custer, at the factory and talked to some of their staff. And
Big old, oh, we didn't talk to anyone. We just went to the big old mountain hill. Well, we did. I had a meeting before.
They let you near all their equipment.
and I can't help but, be amazed at the ingenuity of our human family to go from there to there to, well, I'm not drinking out of a cup today, but so, who's, other than Vi, because I know she'll answer every one of these if we go to her, who's got something on soda feldspar?
Well, I do. It says it lowers the infusion point of the bodies or the glazes slightly. That's all I have written down.
If you look at the melting point on the far right of each of those, in general,
It's less.
what you can see that it's a lower temperature at which it melts. Now, Vi said that with potash feldspar, it actually begins to melt lower, but then it sort of stabilizes. What's most important for you to know, besides the fact that a soda feldspar does lower the melting rate, take the same glaze and substitute soda feldspar for potash feldspar. The glaze will melt more than it would with the potash.
Because it's a lower temperature melting.
Right. Now, there's something really important about that, which is at the temperatures we're firing to, it's not terribly significant, but it's a discernible change in melting point. And for instance, I can show you right here, these are called fusion tests that we ran. I taught a class a while back called From Earth to Fire, where we talked about raw materials. And each of these samples was by taking a little crucible, packing the powder in, and then tapping it gently and dropping it into each of those slots. And the best part of this is recognizing all the ways people made mistakes in labeling. But these two right here, so the top example, Custer feldspar, F4, which is soda feldspar. I need these back. I don't have enough of them to give them to you. There you go. So you can see that the Custer feldspar melted. You can tell by the shininess of the surface at the top.
Yeah, it's melted more.
But the F4, the soda feldspar, began to float.
Right.
Yeah.
Yeah. What happened to the borate?
Gersley borate,
Yeah.
it's all there. It melted, it crawled up by capillary action up on the side, it migrated into adjacent spaces.
Wow.
In fact,
Really?
if you look at the bottom right, that top tray, but the bottom right-hand corner, you'll see that green glass.
Yeah.
That's Gersley borate.
Oh my.
Wow.
Oh,
That's very
This is
reactive.
Gersley
Yeah.
borate right here.
but that is right there too.
Oh, there, yeah, okay. I was looking at the wrong one.
Yeah, the bottom tray, bottom left tray, you get the
And it's all
Gersley
granular
borate
look.
stayed put.
Granular looking.
What's the
there.
difference
That time,
between the
anyway.
top and the bottom again, Bob? What's the difference between the top? Is that just
Scale.
I'm saying that I said the bottom right-hand corner of the bottom right-hand tray. No, top tray, bottom right-hand corner. You see the green glass pulled up in there?
In the
Yeah.
in the corner, it's
Yeah.
not the
Right
not
here.
the whiting.
That's the
it's-
Gersley borate from the adjacent space.
Oh.
If you look at the bottom tray,
Oh, there.
upper left corner,
Oh, it crawled up and went over.
yes, it did.
Oh, okay.
So the other thing that I saw about soda
Yes.
feldspar was that it was generally whiter in consistency, and that when mixed with other colorants, that the colors oftentimes were brighter with it than with the potash.
Well, that may have some truth to it, although if I look at the Custer and the F4 samples there, I can't distinguish a great deal of difference in terms of brightness of whiteness.
Okay.
What's really important to us about soda feldspar is that it has a different degree of acidity in the melted glass.
Oh. Acidity.
It's more basic than is potash. And the result is it gives entirely different color responses to the same minerals that we used
Okay.
with other glazes. And so, for instance, if we use iron, red iron oxide in a glaze with Custer feldspar, potash feldspar, it'll be sort of earthy yellow, tan, brown color range. And if we use it with soda feldspar, we get some not as bright as Mary Ellen's shirt, but much more vibrant yellows.
Oh.
And if we use copper, we can get turquoise, and there's just a whole different array. So
Depends on what you're looking for and what you want.
always the case. But the most important feature, besides the slightly lower melting temperature, is that the soda feldspar generates more vibrant color.
Yeah, I think that's what this comment was meant. But also, and now I don't quite get this, because they also talked about crazing being a problem in the potash, but it said here that soda spar had a higher coefficient of expansion, which also results in crazing. I mean, you can imagine that a higher coefficient of expansion could cause all sorts of problems.
Potentially. I have not seen any expansion, contraction problems relative to the clay body. And if you keep in mind that at stoneware temperatures, the clay body is vitrified, then we're not concerned if the glaze crazes. In earthenware, low temperature ware, if the glaze crazes, the mature body is still porous. And so water could migrate through the crack in the glaze, through the clay of the body, fired body, and come out the other side. So the only people who are deeply concerned about crazing in high fire ware are the people who make dinnerware for restaurants and cooking types of events where they want the dinnerware to be really beautifully clean looking all the time, and they don't want it to accumulate any debris. And it's not at all unusual with high fire, like old Chinese bowls, they're crazed and there's dark lines where stuff is accumulated. So crazing can be undesirable, and I've got some great examples that I'll show you later, but they're at home right now. Now, potash feldspar, soda feldspar, you need to know that in this studio, Custer feldspar is which?
Potash.
And F4 is which?
Soda.
Because to function effectively, when you start looking at glaze recipes, there are a variety of ways that things can be described, and we'll be talking more about those. Nepheline cyanite is another, and it's a combination of potassium and sodium, but it's characterized as being a soda feldspar in terms of its behavior. Another, it's slightly lower melting temperature, independent of the numbers over here on the side, but it's another source of soda feldspar. You'll oftentimes see it abbreviated as NEPH-SYN, NEPSI. And of course, people in their own private studio writings will use any description they want for materials because it works for them. So you might see NEPSI. What's this? I've never heard of this. Well, the most refractory material in our glaze making is silica. Silicon dioxide. And it won't even come close to melting in the presence of anything but itself. Now, as I said, it was really kind of interesting that somebody mislabeled one of these, and I'll show you what I mean by that here if I can find a sample. Doesn't look like silica is a very popular ingredient in these tests. However, in this one, I think this is different. Yeah, this is different than the one we just looked at. If you look at the bottom tray, you'll see Custer feldspar, soda feldspar, a feldspar from England called Cornwall stone, and in the bottom left, nepheline cyanide.
Wow, ooh, it really melts.
Wow, yeah.
In the sheet that we looked at earlier, in the bottom, I was laughing because it was labeled flint, but it melted like the soda feldspar, and silica by itself will not melt. So, oops. But it should look like a white powder still. So, silicon dioxide, also known as quartz, or if you get a glaze recipe from England, it will be labeled flint.
Oh, okay, because I ran across the terminology flint. So, was it Probably because I
And
booked
if I can have the big crystal,
Oh, okay. Holding my camera up.
I'll give it back to you.
Happened here.
So things like quartz crystals only develop under very highly specialized circumstances, deep in the center of the earth, and sometimes these things make
heavy
their way
enough.
back to the surface. For years and years, the best examples of quartz crystals in the United States came from Arkansas. And they had places where you could go in and pay $5 and take a 5-gallon bucket and then dig through the mud and see if you could find the crystals. Now, if you see ones like this, they're all coming from Brazil.
Oh.
And almost always, the best place to find them is in a rock shop, gem mineral shop. I think this one I got in Arizona.
Jim shows.
Yep.
Gem shows. Yeah.
And, you know, the crystalline structure of that's really irrelevant to our discussion, but it's lots of fun to look at, in my opinion. If you haven't-
Oh, I have tons of this stuff at home. Big ones.
Really?
Yeah.
So our essential glass formers for high fire wear are feldspar and silica.
Looks like an encased wave or something, a water spout.
And there's a word that I will rarely use, but you need to know that it exists.
Oh, oh yeah. Electric. I can never pronounce it.
You guys
Eutectic.
want to look at this up?
And the eutectic is the behavior of materials when we mix them together. There's an optimum mixture at which the two things together will melt at a temperature much lower than either one of them separately. So it's a behavioral process, eutectic, which has to do with managing the blend of materials that give us the best melting conditions that we want. And that's as far as it could go on for a full semester of talking about blended materials and melting points, and we don't have the apparatus here to fire with that level of accuracy where we could do Custer and silica, and change and look for the best melt.
So,
But yes,
I'm sorry, just let me just clarify, with silica has a very, very high melting point by itself.
correct.
When mixed with other things, it brings the melting point down.
That is
Or the
correct.
melting point comes down.
That's
That would
correct.
be a flux,
Yeah.
right? A flux.
No, the eutectic takes advantage of fluxes to bring the melting
Okay.
point into a range that we want to get. But what you need to know is you got two different materials, you mix them together, they melt at a temperature lower than they would separately.
Okay.
Go ahead.
Sharon.
I sure too.
Thank you.
So, in
So,
glass, silica is the glass forming material, Glaze, but glass, sheet glass that we buy, that
Right.
we use, we melt at these way lower temperatures than this.
exactly.
So it has chemicals in it, or fluxes, that bring it way down
That's correct.
to make the lower coefficient?
Uh-huh.
Okay. Okay. Cause this is like over twice as.
Yeah, no, it's outrageous.
high.
It's a refractory material. It's just very, very resists the effects of heat by itself, which makes things like these crystals really fascinating because you think about the conditions under which they form. The surface of the Earth just below the crust is at about 2,000 degrees, and apparently you don't have to. But there's also pressure, which is
Yeah,
another
there's a lot of pressure.
dimension.
That's probably the biggest factor in forming.
Unfortunately, we don't have to worry about pressurizing the kiln to get what we want. So, these are the principal glass formers for high fire glazes, but I did add one in that same list before we go to glass modifiers, Gerstli borate. Now, borates are very low temperature glass formers. And you saw at cone 10 in those fusion tests how profoundly the Gerstli borate melts. Becomes very liquid, it overcomes gravity, climbs over the walls.
Yeah.
But you just need to know that occasionally somebody will have a high fire glaze that calls for some Dursley borate. And it's not only a glass former, but at that point also a powerful flux.
Yeah, it's a low and mid-range glaze.
Right.
flow.
And it's one of the most popular ingredients in raku glazes. Raku glazes are low temperature, low fire, somewhere around 1800 degrees Fahrenheit. Okay, glass. Oh, more story about Dursley borate. Borates are naturally occurring minerals of boron. They occur in locations that had great inland lake beds that evaporated. They're sometimes called evaporites. There are many different minerals. Gypsum, salt are among those, which will precipitate as the water evaporates. You get these layers in these ancient lake beds. Mr. Gerstly owns a dry lake bed east of Death Valley.
That doesn't surprise me.
And Mr. Gerstly got tired of digging up his lake bed, and so he just announced to the world there was no more Gerstly borate.
Not the story, yeah.
Freaked out the studio potter community. People's trying to figure out what they can blend together to create that. The vice president of Laguna Clay Products down in L.A. went up to Mr. Borate, Mr. Gersley, I mean, and purchased the remaining inventory. And took it back, and they sold it, and then they announced there wouldn't be any more. And they got back in touch with him, and Mr. Gersley decided to mine some more. And suddenly it came back on the market. Now, the odd thing about Gersley borate is nobody runs chemical tests on it, so you're digging up an ancient lake bed, who knows what's really there. But it still is very popular for low fire glasses.
Okay, the story
And it's
I
only
got-
sold to two companies in the country, Laguna Clay Products and Hommel Frit Company.
I got out of that it was in 2000, U.S. Borax ceased their operations at their California Gersley mine. In April of this year, Laguna Clay Company became aware that there remained a limited amount of the mineral in that mine. Arranged removal and is now milling it. That was
The story I told you was told to me by the vice president of operations at
Okay.
Laguna. Now,
How long ago
maybe
was it told to you?
About 7 years ago.
Oh, okay. Well, this was as of this year. This was what I got this from because it's this year So U.S. Borax somehow got in the middle of it.
Well, they are. I mean, if you remember, 20 Mule Team Borax,
unless
Ronald
there's
Reagan is a
a,
spokesperson.
Yeah,
Yeah.
I do.
If you drive Highway 58
Yes, you can see.
east toward Barstow,
Yep,
you
through
go
the
right through the town of Boron,
yep.
and
The middle of nowhere.
U.S.
Right.
Minerals is right over there.
then
with-
20
you
Mule
see the
Team
operation.
Road is right
Yeah.
goes in or out
Anyway.
of it. If you take
So-
178, you go to Death Valley. You go by where the Gersley mine is, past
So-
Trona.
Yes,
It's also called comonite, right?
that's another name for it, sort of.
Sort of.
Well, okay, wait,
Yep.
let me finish my question.
Yes.
Okay. So, is comonite available outside of boron, or are you available? I mean, is it a separate mineral distinction, and
Well, you
separate-
can see that it's a combination of calcium oxide, boron oxide, or boric oxide, and crystalline water, not liquid water. And that's a theoretical model. We're still digging up stuff out of the ground that happened thousands upon thousands of years ago, so they're highly variable. Comonite is a superb product in the industrial making of glass. There are no comonite sources in North America that are pure enough to satisfy our glass-making industry. So they import comonite from Russia or Argentina. They don't use what's available
Guess we'll be
locally.
doing more from Argentina right now.
or Russia?
I show that it's a conglomerate mineral made up primarily of colemanite, whatever ulexite and hectorite, and that it's a natural borate similar to but not interchangeable with colmanite on a one-to-one basis.
That all sounds fine.
But,
Yeah, it's
but you put
Accurate.
colmanite as its name up here next to Dursley borate, so.
because in this, remember, there's a difference between the industrial purification of materials and potters.
Okay, but I got this out of clay books.
And the ceramics folks have tended to use them interchangeably.
Not guaranteed
No,
to
no.
create a specific,
And when you're doing raku, you don't have that level of control anyway,
well,
so.
yeah. Ah, just throw it in, what the heck.
Okay, so, we talked briefly, and only we'll talk briefly about the eutectic, about mixing things so they melt at a desirable temperature. We looked at silica being a very refractory material. So it is, first of all, you won't see any glaze that's pure silica. Operationally, doesn't affect our standards or our interest. One of the most popular fluxes is called whiting. It is calcium carbonate. It is the same thing as seashells and limestone. And it has the interesting characteristic of from 1 to 25%, it will lower the melting point 25% as a component within the glaze recipe. From 1 to 25%, it will bring the melting point down. But if you increase it to above 25%, it begins to push the melting point up. I'll give Linda that research project and she'd come back in 3 years and tell us why.
You don't think she could do it quicker than that?
I know she doesn't have a lot of spare time.
Good save.
She's good and quiet too.
Now, what I want you to take note of here is if you look at the column that is the natural state column, it's always the chemical notation on the left, you'll see that it's a combination of an atom of calcium, an atom of carbon, 3 atoms of oxygen. The carbon and oxygen is usually referred to as the carbonate. It's with many, many minerals. But if you look at the post-firing recipe, it's not just calcium oxide.
Right.
And so in the process of the firing, the carbonate radical is released in the form of CO2 gas. And that CO2 gas has to escape from the glaze, and it does so by combining with other little tiny specks of that gas until it makes a bubble. And the bubble then comes to the surface of the glaze, where like any soap bubble, it's got a skin over it. And then that eventually it pops, and the skin folds back into itself, and eventually, given enough time, will smooth out, and then you have a smooth surface. So if you don't fire long enough, you can end up with lots of pinholes
Or under firing.
either from under firing, but every glaze goes through a phase in which the glaze boils or off gases during the firing process. And if you remember that sample bowl that was half bubbled, this one.
Yeah.
So all of those were places where the bubbles burst, but because of the unevenness of reduction, the reduction was good on this half, and it provided additional fluxes that helped the glaze melt. On this side, the glaze didn't melt as much, and so we see those bubbles after they burst. And if you look at them closely, you can see each one is surrounded by a slightly thick rim of glaze.
I've had a couple of those.
So now if that had been fired longer, would that have removed that, or would it have?
Well, the primary issue that was the lack of reduction on that one side of the bowl. And so the other minerals that would have turned to more powerful fluxes didn't. Given enough time, yes, those would smooth out.
Okay.
Hard to say how much time that would be.
But that had to do with the placement in the kiln, basically, that
Yeah.
Right.
had a
But
cool side.
Well, it wasn't just cool, it was the lack of reduction. The flow of the gases in the kiln.
Yeah.
So we got this side of the piece perfectly melted. There's not gonna be that much temperature difference over a piece that size. But without the reduction on that side,
Wow.
then we didn't get all the melting potential of the other minerals.
Sometimes when you're glazing and you dip a glaze and you get all these little bubbles.
Those are the gas that are it's inside the bisqueware escaping. When you put the piece in, you've got water going into the bisqueware, it displaces the gas that's causing it to come back out.
So should one go like that? And
After it's dry?
After
Yeah,
it's
yeah,
dry?
just move the
Okay.
glaze around a little bit.
Oh. Very good.
Anyway, so whiting is a very useful, very regular fluxing agent. I've included kaolin and ball clay there because they are the glue, and they tend to be 10% or less of most glaze recipes. Keep in mind the characteristic differences between primary clay and secondary clay. Who can take a shot at describing? Yes, Kathy.
Real simple. Primary clay is clay that comes directly out of the volcano. It's the piece of rock or clay that comes out of the volcano and comes down and I guess stays. I'm not doing this very good. And secondary clay is clay that flows down, gets into riverbed, gets other materials and other stuff. And that's called secondary clay. That's bad.
So that's the key elements there were all clay comes from igneous rock, doesn't have to get to the surface as a volcano. It can cool depth, but eventually ends up at the surface. Now, you're about to say?
Well, yeah, unless you want me to, yeah, it has to do with the purity and the particle size.
Okay,
Yeah.
so
Whether it
primary
has
clay is
particle-
chemically pure, relatively large particle sizes.
And
The-
it's less plastic.
Due
Yeah.
to the large particle size and the amount of water that it takes to wrap around each of those particles, it is less plastic. Secondary clay, as Kathy indicated, has been transported typically by water. It gets pulverized and ground up into smaller particle sizes, and most often also picks up a lot of other chemical contaminants in the process. Smaller particle sizes, increased plasticity. Increased plasticity also means increased shrinkage when it dries out. And so if you've got a piece, a high fire glaze piece that has ball clay as the clay in it, because if it's a fairly pure ball clay, it's got basically the same chemical signature as the primary clay kaolin. But it's going to shrink more, and it's sitting on the surface of a piece of bisqueware, which is not going to expand or contract as it gets wet and dries. So the ball clay is going to cause higher shrinkage of the glaze layer you've just put on there, and therefore sometimes problems of separation where the stuff peels off of your bisqueware. A lot of things that can cause that, but one of them is having too much ball clay. So in almost all cases, we use kaolin as the glue component in our high fire glazes. And in this studio, that means we use Edgar's plastic kaolin, known as EPK. But because of the Chinese early use of kaolin and the initial formation of porcelain, kaolin is sometimes referred to as China clay.
Is that why also they say to be a little bit more careful versus working with or a WS10 versus a porcelain? Because the porcelain, you have to be more careful with it because if you're building with it, it has more of a tendency to shrink more and crack more.
It has no grog. Grog serves to reduce shrinkage because it's a non-plastic medium. It also provides greater stability to the forms you make. And if you use a clay with high plasticity, then you have, when it gets wet, lots of expansion. When it gets dry, lots of shrinkage
More cracking.
and more cracking potential, yes.
I have a question. I don't know if it pertains to right now. You can answer it now or later, but I know when we were making the canine, we were using ball clay for a long time, and then somehow or another you made a little change in that and made it easier to work. Can you eventually explain to us how you did that? I mean-
Intuitive guess.
Well, I mean, you took away the ball
With your
clay,
knowledge and experience,
Yeah.
a good intuitive
Switch
guess.
to kaolin, right?
switched to kaolin, but then we added something else too.
A material to help keep it from settling to the bottom of the
Yeah,
bucket.
yeah.
That's something to
We'll talk about
suspend it.
those later.
Okay, okay.
There's
'Cause
some-
I thought that was really
Called a
interesting.
deflocculant.
That was super.
So talc and dolomite are very similar to whiting in terms of their function. Dolomite provides both calcium and magnesium. Talc uses magnesium as the source of its fluxing. What have you got there, Kathleen, for talc?
Talc, used in glazes, it will promote a slightly opaque glaze, make iron produce browns, and alter the intensity of cobalt oxide. This compound is an insoluble magnesium compound that is sometimes used in cone 04 to 06 white bodies to lower the maturing point.
Okay, so we'll sort of ignore that last sentence because we're
Okay,
not
sorry
worried about
about
clay
that.
bodies. But glazes high in magnesium do tend to have a different set of color responses. And they tend to have a surface which is oftentimes described as buttery. Not color of butter, but a surface of butter.
Or matte.
Semi-matte,
Yeah.
yeah, they're not dry mats. And there's a potter down in Southern California, Dick Fassbinder, who used a high magnesium matte glaze exclusively, and then, excuse me, and then he would paint mineral oxides over the glaze and get an entirely different set of color responses. The oxides and the magnesium interacted during the melt. I have the whole list of that if anybody's excited about trying Fassbinder's glazes.
That interests me.
You will also see in glaze recipes that many of them include whiting and dolomite or whiting talc and dolomite. They will add those together. Somebody somewhere has come up with the recipe and they added multiple fluxes to get the job done. Barium carbonate is a very strange material. Kathy, do you have something written for barium carbonate?
I put used in glass recipes to introduce the oxygen, what did I write,
Baria, yeah.
Baria. In glazes is used because it is insoluble. The barium is the most difficult of the carbonates to decompose. It breaks up color rich.
Barium carbonate. Excuse me, I tried to breathe a small bit of peanut.
Is barium the one that's hard to mix in with other glazes?
Barium is something you shouldn't use so much of.
Barium carbonate is not water soluble,
Ah,
so it remains in its pure state when it's mixed into glaze. When it's fired, however, it yields barium oxide, barium. Barium oxide is potentially a heavy metal damaging in toxicity to the human body.
Yes, I have it as poisonous hand.
Lots of people are concerned about using barium in their glazes. Tom Coleman, who's published 3 books of recipes that he's excited about, every single time he uses barium carbonate, he writes sort of toxic, kind of thing. And that's just nothing more than a legalese self-protection. I would say from all the research that I've done that the judgment about barium carbonate in glazes is still completely out there. There's no consistent issues. But some people wanting to remove barium carbonate or barium from their glazes have switched to strontium carbonate, which doesn't sound any more satisfying to me.
No.
But if you do that, you use, for each part that the recipe calls for, 1 part of barium carbonate, you use 3/4 of a part of strontium carbonate.
Oh.
That's the substitution ratio somebody's worked out. Now, based on all of the things I know about glass solubility, if you are really concerned about this issue, then you probably don't want to use a barium glaze on the inside of a bowl where you're likely to put a lot of salad dressing and vinegar.
I said, it does, do not use for functional wear. Just don't use it.
I've been using it for years, so I'm not terribly concerned. I've been breathing dust for years, and I'm still breathing dust. So.
Shall we turn the lights off and see if it's on the top?
No, I don't use strontium. So, here's what barium gives us. It tends to promote a breakup of color. Instead of having an absolute uniform color, it tends to give mottled coloration. For some glazes, that makes the glaze more interesting when it's fired. Barium also promotes the growth of microcrystalline structure in the glass as it cools. Mm-hmm. There are 2 ways to get a matte glaze. I mean, this has got a little bit of shine to it, but basically it's a matte glaze.
Yeah.
You can either create a microcrystalline structure through the use of barium, and as the shiny glaze, as it cools, these little crystals develop in the glaze that mat out the surface. Mm-hmm. The other, which is what this is an under-fired matte. Mm-hmm. So if we wanted to, we could take this glaze and fire it to a higher temperature, and it would probably come out glossy. Mm-hmm. But we've designed the glaze so that at cone 10, it doesn't develop a shiny surface because it's not fired hot enough to get shiny. Almost all matte glazes that we use in the studio are under-fired mattes. And if you fire them high enough, they'll become a glossy glaze. So it's intentional. Yes, go ahead,
But
Allan.
dolomite.
Dolomite.
Flux, it says when 10 to 25% is added, it gives a silky matte finish.
Well, it has some of the same characteristics I was talking about at whiting when you get above 50% or 25% with whiting where it begins to raise the melting point. So at high concentrations, you've got calcium and magnesium in the glaze.
Mm-hmm. Yeah.
But whether or not it creates a silky surface has more to do with the overall blend of materials. It's probably still an under-fired matte, meaning if we fired it to cone 14, it would probably be a glossy glaze.
Okay.
But we're not going to do that.
No.
We desire that surface. Mm-hmm. But the reason I'm discussing it right now with barium carbonate is you can also get a glaze which melts, becomes incredibly fluid, but will be matte after it's cold.
But it'll still have this fluctuation, this mottled look to it,
Yeah.
and that.
Uh-huh.
I'd like to see a fired piece.
And we have a number of glazes that count on barium carbonate to do some really interesting things. Mm-hmm. One of those is a group of glazes we'll refer to soon as titanium blues. Mm. Sounds like a great band.
Think of
but-
another poisonous.
Okay, I'm turning on to page
Oh,
3.
it's cadmium that's so bad.
Bone ash.
Bone ash is exactly what it says it
Brown
is.
cattle bones.
We are in a quasi semi-industrial agricultural world in which they try to make as much productive use of parts of the animal. They're not all filet mignon. They're grind up the belly meat. But bone ash has the wonderful and strange behavioral characteristic by contributing phosphorus to the glaze. It allows the reoxidation of iron at the surface. Last week I showed you a glossy black glaze and another brownish reddish glaze, and we looked at them broken, the cross sections, and both of them below the surface are black, but the iron red glaze has reoxidized while cooling. And that's due to the presence of the phosphorus contributed from the bone ash. So anytime you see a glaze recipe that calls for bone ash, you can reasonably anticipate if there's iron present, it will reoxidize during the cooling on the surface and generate some of those richer red, iron red color tones as opposed to brown or black. Anything to add to that, Vi?
Thin coat of bone ash creates a surface sheen on the clay body. I like that.
Okay.
And it produces opacity and whiteness.
If you took the iron red glaze and mixed it up without adding the 11% red iron oxide to it, it comes out a real milky, creamy, it's sort of frosting-like, but not, it's semi-translucent. Kind of, it's just interesting. I did that, I was curious, because then what I did is I took that glaze and then I painted iron decoration onto the surface of the glaze before it was fired, and fired it, and so I got the red where the brush lines were and the gray-white elsewhere. Spodumene is a very strange material. You can quote me on that. It is a lithium compound, and the lithium behaves in the firing unlike any other of our materials. Everything else, when you heat it up, it expands. When it cools, it contracts. The lithium compounds, when you heat them up, they expand, and when they cool off, they don't shrink.
Yeah, I have corrects crazing in glazes when substituted for feldspar.
If you think about what crazing is the glass on the surface of the fired piece is shrinking more than the body,
Right, so it cracks.
and it develops this network of cracks. We call those crazing. So if you add some spodumene to replace some of the feldspar, you're now going to get a situation where the glaze, as it cools, doesn't shrink as much. Can help eliminate the tendency for the glaze to craze.
I wonder why it doesn't shrink back.
It's the nature of the material. It's an observed phenomenon. I can't explain what about its crystalline structure where
Something to do with the lithium, probably.
well, yeah, yeah, but it. So people who want to make what's called flameware,
Oh, yeah.
make ceramic
yeah, flameware
flameware,
too, yeah.
ceramic frying pan,
Yeah.
Oh, yeah.
add spodumene to their clay body to do
So
that.
if I wanted to make a bacon press, spodumene would be a good thing to make on a bacon
Yeah,
press.
because most of the fired ceramic pieces, when they heat up, if you don't heat them up uniformly, create stresses that cause them to crack.
And that
So
makes
if
it
you,
neat.
the lithium compounds seem to take care of that.
But
Yes,
can
Lou?
you use this on the inside of functional wear? Spodumene.
Oh, I do all the time.
Okay,
Yeah.
because I was told not to, so, but that's not one. Okay.
Yeah, and what's the source of not to?
An instructor told me that I shouldn't use it on the inside of functional wear. So it's
Yeah.
like, okay, that's why I'm taking ceramics 3.
Well, and people have opinions. That's the best part of peopleness.
Okay.
Always some of the most obnoxious parts of peopleness.
I'll drink to that.
Magnesium carbonate is the second most strange material. If I handed you Kathy Havelka, 5 pounds of material. Show me how big you think that would be, just in general.
Of
Dry- fi-
magnesium
No,
carbonate.
no, just 5 pounds of any of those glazed materials.
Mostly, something of 5 pounds would normally be, you know, let's say for rock.
It does depend how concentrated it is, it's true.
Yeah.
My
Depends on the
sister just sent me
material.
5 pounds of diatomaceous earth, and it was
wow.
like this.
Okay.
Oh, I would think it'd be.
So normally, that's 5 pounds.
Yeah.
1 pound, 1 pound.
I was through the 1 pound.
Let's see,
Okay.
5 pounds of
454
vermiculite would
grams.
fold.
Okay.
If I give you 5 pounds of magnesium carbonate,
Really?
it's like a bag of feathers. It's just weird
It's
stuff.
really light then.
Yeah. So we added as
Low density.
we added as a flux. But really, what it does when it gets hot is it shrinks like crazy. Look at the melting point.
Oh, yeah.
Oh, my.
Wow.
Almost do that in your home oven.
No, 572.
Oh, I'm down to wrong. Oh, that's not very high.
That's correct. That's
So
it.
when you heat it, it shrinks?
It shrinks.
It shrinks.
I'm in the wrong thing.
So if we put magnesium carbonate in a glaze, very early in the melting of the glaze, it's going to shrink like crazy.
Yeah, yeah.
That is
Gonna cause.
different than crazing. It's called crawling, where the glaze literally crawls apart from itself. We use that in low fire glazes to make stuff that we might call lizard skin.
Get out the Vaseline, please.
In high fire glazes,
Oh, yeah.
here it's called spodumene. No, what's it called? Crawl. It's back there. I remember. I haven't used it in so long.
Magnesium carbonate, like that. No, we're on, yeah.
Yeah.
we're
So
on
we've
magnesium carbonate.
introduced magnesium carbonate to create a glaze flaw, which some find as
Lovely.
Appealing, yeah.
appealing.
Yeah.
So this is on Amador. So the color is from orange to dark brown, depending on thickness. And the extent of the crawling is dependent also on the thickness of the glaze application.
I saw Mike, he did a piece where I go, how'd you get it to be such a big, you know, crackly, crawling pieces like that? Because he poured it on real slow and let it slowly go down the side of the bottle.
Yep.
The
Mike
more
does some
thicker and
weird
slower, it
stuff.
was a thicker application
Right.
put on very.
So in this one, the thicker the application, the lighter the color, and the larger the clumping.
I like it. It's just,
But
it's
this is what they're saying, not good for function wear because of the bacteria can get in the cracks and stuff.
A little hard to clean up, yeah.
Yeah, harder to clean up, yeah. This is what people were saying.
But you couldn't go back and put, a clear glaze over that and refire it.
Oh, sure.
And,
But I don't know what it would do, but you could do it.
I mean, would this underneath
feeling,
here start to, you don't know if it would react on it.
No,
until
I've
you
never
get a
tried
crinkle
it. I
in.
mean, to me,
Try
that's a
it.
perfect
find
example.
out,
I
let us
too.
know.
Yeah.
Oh, yeah, I see.
It
It's
could
almost
change
like they had a
everything.
wax
That's just kinky
resist on
right
here
there.
somehow.
It is. It's like,
It cools and just really cools.
yeah.
So this is one of the ingredients that it can be used in high fire or low fire, but it has this peculiar
Hoping it crawls.
behavioral characteristic which may or may not suit your purposes. Now you put it on one of our white clay bodies, it does the same thing, but it's not at all interesting to look at.
Oh,
Those globs are all white.
so that's the
You want it
clay
for a
body
texture.
showing
The
through
iron,
here.
the iron from the body, yeah, and in between
Okay.
spaces. Now, because there was glaze applied to it, there's a very thin amount of glaze on the clay body when that stuff
That still remained.
is still there.
Okay, because
Right.
it absorbed into
A
the
little
clay
bit.
body, so
Right.
you can't really, this.
It's got an interesting feel,
pull it
doesn't
out.
it?
Yeah,
Uh-huh.
it does.
Yeah, it doesn't look that smooth
Yeah,
feeling.
you could do a
if you Look
cat.
at it from a distance. That would
Oh
give
yeah,
it
it'd be like one of those orange caddies.
Yeah, that could be very interesting.
That might give it very interesting texture.
put it on an armadillo.
Okay, this is an ingredient we don't see used a lot, but nevertheless, it's a
Magnesium carbonate.